All right, good morning, everybody. I want to welcome you to a pretty impressive webinar from Vivid and Hewlett Packard Enterprise. It's on the Predictive Defect Convergence functionality for HPE ALM. Of course, as I said here, brought to you by Hewlett Packard Enterprise, and that is actually me, Matt Braleyberger. I'm actually a product marketing manager with the application lifecycle management business, focusing on ALM, Quality Center, and this new predictive capabilities. Fortunately, I'll only be doing a little bit of speaking here this morning. Megan Sheehan is our senior product manager, who's also with Hewlett Packard Enterprise. Megan's got a pretty amazing background in data science and product management, working for companies like Infogistix and Microsoft. Provides an awful lot of technical background, and also very, very articulate. And I think this is a very, very exciting session here in general, because we're talking about how we can leverage a lot of the information that a lot of organizations already have today. Just for some housekeeping, this is, of course, a live session that we are recording, and it's available for all Vivid members after the session. There will be Q&A as well. If you have any questions, I'll go through that here in just a second here. We'll have some dedicated points where we can actually answer some of that information. We are also looking to provide a live product demonstration here as well a little bit later, so you guys can see some of this functionality live. Now, in order to actually ask a question, you'll see in the webinar control panel for GoToMeeting, there's an option in the questions or chat area where you can actually put your question inside. We may read out a few, we may answer a few inside, but ultimately, if we aren't able to get to every single question today, there will be answers to the questions in a document that'll be posted on the Vivid site with this presentation fairly shortly afterwards. All right, so what I'm going to do is I'm going to go ahead here and we'll get things started. So again, my name is Matt Braleyberger, Product Marketing Manager with Hewlett Packard. We're going to talk about some brand new functionality that is actually available in small portion currently. So, oh, somebody needs to go on mute there.
Yeah, Matt, were you hearing that too? Okay, I thought it was just my imagination. Okay.
No, that's all right. So I guess one of our technical assistants may need to provide mute for themselves here. Now this is interesting, because if you've got ALM and Quality Center, and you've been using it for a while, a lot of the data that you've got stored within your system provides an awful lot of potential for insight. And actually, this is what we're looking to do with some of the pieces that are already available currently, and there'll be an awful lot more that Megan will talk about coming up in the future, likely, where we're trying to go with some of this functionality. So Predictive Defect Convergence is the first piece that is available right now, and I guess I'll start off by just reminding everybody on the session, just a private session here with just a few hundred of our friends.
Of our closest friends, yes.
Of our closest friends, exactly. So this is some forward-looking statements. Some of the stuff could change within the functionality and some of the things that we're looking to deliver. This is the normal stuff that we talk about with anything that may be upcoming. Again, a lot of this stuff is available today, and that's what we'll talk about first, but there's a longer-term vision that we've got behind the technology and some of the functionality that we're providing here. So just that reminder that some of the stuff is subject to change, and as we all know in the software industry, probably will change as we begin to roll this out to some of our customers and as we get additional feedback.
And Matt, I'm going to go even stronger on that. I would say yes, things will change as we build more algorithms and as we learn from it. Absolutely, things are going to change. What we're sharing today is our most current knowledge on our plans and our best estimates, but expect that absolutely in the next 3 years there will be changes.
And it's very analogous to the whole idea of the predictive learning and the computer-aided learning algorithms, where we have stuff always being constantly reassessed and adjusted and all this things like that. So it's all part of the fun here.
Oh yeah, absolutely.
I'll start off here by talking about why big data matters in ALM. Again, not everybody has the same background, of course, on these sessions, and so I'll just take a few brief moments to talk about, well, what do you mean? What is big data within the context of what we're talking about? What are some of the things that we may be able to do with some of the ALM data that we've got in our technology already today? And I'll talk about just some of the very high-level concept stuff. Megan will get into sort of the lower depths of what predictive defect convergence is. Again, this is available currently today. You can get that on the HP Live network, and we'll talk a bit more about that at the end. Megan will also go through a demonstration, and we'll talk about some of the feedback and things that we're looking to get through the process, because again, this is an iterative cycle as we begin to release some of this functionality to the customers and to the various test environments. Of course, we're adjusting some of these algorithms as we go ahead. So why does big data matter in ALM? And I thought this was very interesting. I read an article in Forbes that talked about really big data represents a fundamental shift in how we do things. It opens the door to this thing called a Bayesian approach to strategy, where we no longer try to be right based on controlled research and small samples, but become less wrong over time. And the concept is, Bayesian strategy is, I for all intents and purposes, set a goalpost, and I begin to look at an algorithm or create some sort of a strategy to get to some sort of an end mean. And as I get new data, I then adjust my algorithm and keep shifting and moving so I can actually get some sort of an approach or a strategy that really does represent something that's the success. Now, one might argue if this is a science, we should be able to do things arithmetically or be able to look at large quantities of data and make sense of them. The challenge is in some large systems like software, and certainly like team-based things where we've got people involved in the process, people always add an additional element of complexity. There may be just such a large quantity of variables and interdependencies that it's just difficult to algorithmically pull things out. Even though there may be logical connections, just the quantity of things become so hard and so challenging for organizations. And so again, this is the approach of, let's put some sort of a goalpost out there. Let's find some sort of an algorithm that provides some sort of a meaningful result, and as we get new data and run certain trials, let's adjust that algorithm over time. And it's not quite trial and error because it's certainly a little bit more scientific than that, but the idea is we're trying to get through adjustment to an algorithm or some sort of a repeatable process where we're able to get what we call the right answer. Now, big data is one of those terms in software and in the industry that gets overused often. So one of those buzzwords if you're playing buzzword bingo. But I mean, you already see, if you've got a cell phone and you're within the United States or Canada or even Europe, you're already seeing big uses of big data in your environment. People are taking the things that you're doing, they're beginning to add algorithms and applied computing technologies to try and understand certain pieces of information that we can maybe use for marketing, for medical research, for environmental sciences, all sorts of things like that. If you're using Android, for example, Google does a fantastic job of actually taking things like your locations and your buying preferences and when you're on your phone and not, and beginning to build profiles of the individuals that we can then predict future behavior. And of course, prediction is what we're all trying to go towards when we're talking about using big data and some of these algorithms. But the key is that this is already stuff that's in use today in different domains. What we're talking about doing is taking some of the stuff that's already in the ALM product, lots of different fields and histories and transitions of data and what users are doing, and begin to construct future predictions based on your past insight. And it's interesting because the larger your data set, the more accurate these results end up being. And so when I've talked to organizations in the past, and we've got fortunate to have a lot of very large customers using ALM out there, a lot of the conversation gets down to, you know, the data source just becomes so large. Our database gets big over time. Well, yes, and rather than necessarily archiving or putting that away or, heaven forbid, deleting it, this stuff actually provides incredible value to the team as a whole. And so this is using really, I've got sort of a diagram on the right there that's really talking about our process. This is where we've got data and metadata that's actually pulled into our data science bucket, as I'm calling it here in my funnel, where we actually apply computational science and this concept of machine learning. Machine learning is effectively the ability for an algorithm to adjust itself based on looking at its predictions and then the actual end result, and then tweak and then run the set again until we get something that's an awful lot closer to where we need to be. But this is, again, something that's already in use in a lot of different models. What we're doing is transcribing a lot of that, or maybe even better, we're mutating some of that concept that may be used in something like marketing and then trying to apply it to things like software development and structured team technologies and stuff like that. But again, starts with theoretical model and then how that model is applied, and we observe the data over time. The key is that this is refined. And I remember when we talked about some of the early phases and iterations of the predictive pieces, gosh, even last year, we had sample data with customers and we were always adjusting the algorithm. It was adjust and then look again, because you look at the past history, and if we could predict something that was accurate based on what past history actually showed, we'd have something that may work, but then you'd have to go to a different customer, look at their data, and then adjust over time and so forth. So there's a lot of different recommendations we've got about how you use ALM properly, and Megan will talk about that a little bit later here. and what fields and values you should maybe be looking to categorize in order to make this most valuable to you and a team. But again, the key is what we're using is an algorithm. We're using technology to actually drive some sort of a business outcome from what we see in the past potentially as large quantities of data. Now, if we step back for a minute, this is very interesting, and I would argue an incredible leap forward when we look at application lifecycle management or the whole concept of just software development. A lot of technologies push their capability and very, very aptly beat their chest about how well we can predict, or sorry, how we can report on stuff that's done in the past. Very few talk about the concept of prediction. ALM and Quality Center are very well known, fortunately, again, through our involvement in our customer community, in being able to report on information that we've seen in the past. And we can make suppositions, and a lot of smart managers and team members will be able to guess intelligently sometimes what we believe future behavior is going to be, but we're not often very correct within a certain reasonable margin. What we're talking about now is the ability to take that data and to predict the future. And again, I'll let Megan talk more about the details here shortly, but it's all the way from, if you think about your data being in ALM related to defects and then tests, and then you've got requirement information. And what if we're using the ALI capabilities and connecting it to development? There's a whole host of things that we suddenly become able to do if we can throw the right algorithm against the right quantity of data. Now again, in big data, this is very important to us, and this is very important as we're going through our own development of our functionality here. Focusing on the right questions is really that critical first step, because if we don't know what we're trying to get, not the right answer necessarily, but sometimes maybe it is the right answer, but it's a focus on what we're ultimately trying to achieve. It's very difficult when you put anything that moves as quickly as some of these self-learning algorithms against a data source if we're not clear on the outcome. The analogy I may use is, if you had a really nice sports car, a nice Ferrari or something like that, and if you didn't know where you're going and you just press the pedal, it's going to go wherever the car feels like going. But if I've actually got a driver behind the wheel and can orient that, I've actually got a very powerful machine that's at my control, and I can actually get some fairly impressive things done with it. Now, of course, Ferrari is very expensive, and I would never own one, but God, they're really nice vehicles. So the other question is always, how big is big? And again, Megan will have some recommendations, and we'll have some more information we'll talk about in this session, but also in some follow-on documentation about how much data you likely need within your system in order to be able to get real value out of this. And that's always the statistical analysis quandary, is what is the right set of data to be able to draw meaningful conclusions from? And so is it a year's worth of data? Is it thousands of records? Is it hundreds of thousands of records? And as you might expect, the answer is always it depends. So again, some of the ALM data that we've already got today here, there's a lot of stuff we've got to work with: requirements, test plans, test runs, defects, and again, the larger the site, we're finding the more insightful some of the predictions can ultimately be. But it doesn't mean if you only have a year or so of project data underneath it that you can't get use out of it. Of course you can. It's just you get varying degrees of call them correctness on the predictions as you get larger and larger quantities of data and as you're doing larger things. And again, I sort of threw this out earlier because I think it'll be the common theme as we go through this. The question we got even last year as we started going through the early phases of developing this was, well, what do I need in my ALM or Quality Center system to actually make this work? And so fortunately, Megan's put together an amazing white paper that she'll talk about a little bit later that talks about exactly that. So what I'll do at this point here is I'll pass things over to Megan, and Megan will do most of the talking now and talk about predictive and some of the other pieces here. So Megan, I'm going to let you continue from here.
Okay, thanks, Matt. I'm trying to share now. Let me know when you can see it.
You are good to go. Yep, looks good.
Okay, here, let's put this back into projection mode. Okay, great, thanks. Matt, thanks for the intro. Thanks for the summary. I felt you were on a roll. I thought you could just keep going, but anyway, let me jump in. And thank you, everyone, for joining us this morning. As I'm sure you've noticed, Matt and I are really excited about this. We're biased, but we think this is one of the coolest things that not only ADM, but HPE are doing. And so we're so happy to be able to share this with you. And before I start talking specifically about Predictive ALM, which is going to be the bulk of our webinar, I do want to mention that all of the things that we are talking about with this go hand in hand with next-gen ALM. So all of the improvements, the changes that we're making there, and Matt, maybe you know a little bit more about our upcoming plans for webinars or other information on next-gen ALM, but for anybody in our audience who hasn't heard about it already, I would strongly recommend that you do attend some of those sessions to find out, because we're really excited about that too. There's a lot of goodness being added to it, and it will absolutely improve ALM, but it also sets us up for predictive ALM too. So Matt, I'll now let you answer the question I asked you.
Yeah, no problem. So actually, we're looking to try and get a webinar together in about the March timeframe, probably early March, just to talk about this. So again, for anybody who's got ALM today, we're not talking about making you buy a new product. This is just the next iteration of what ALM will become. And so because there is some new stuff that we're adding to it and changing some of the usability, I'd argue for the significant betterment, we want to have some sort of a webinar. And so stay tuned. It'll very likely be a Vivid webinar coming up in March.
Right. And the good point, Matt, this is not a new license. Like, this would be available to our customers under the licenses that they have now for ALM. But anyway, more information about that will be coming. I want to mention that in addition to the UI changes, the architecture beneath it, and I think I'm biased, but that's what I'm most excited about, because we will be building in more data integrations, more synchronization, so that we're able to pull more information into ALM. And I keep thinking of it really as the hub, where you can look and see what's happening across your life cycle, and then, from the predictive perspective, that enables us to create algorithms that right now aren't possible because we don't have any way to combine these different data sources. And so with that, let me start on predictive. And as Matt mentioned, like, the whole idea behind this is that we can leverage data you already have, that you may not even be thinking about it in this way, all of your existing ALM projects, and within that, the requirements, the defects, the test runs, and all of the metadata associated with that. Every time you run a test, there's metadata that's collected too. And for most people, it's just kind of sitting there as dark data. It's unanalyzed. And what we are doing with our algorithms is figuring out how can we unlock the insights that this provides. And we initially started down this journey in large part to solve some of our own problems. And then when we realized that, wow, hey, some of the calculations that we're coming up with have not only strong predictive capabilities, goodness of fit measures, but are really useful, we also thought, hey, many of our customers have the same headaches that we do. And so we're now in the process of productizing these algorithms that we've built. And, we're using some pretty standard techniques in terms of machine learning, pattern matching algorithms, cluster analysis, and a lot of these techniques have been around for a long time. What's new and most exciting now is that with the processing power that's available today, and with the large data repositories that we have, we can now mine information in ways that just wasn't possible previously. And so we are doing all of this with the goal of providing actionable insights and recommendations. And so Matt was talking about prediction. Absolutely, that's a big piece of it. But we're taking it a step further even. And instead of just saying, here's what's going to happen, we're also looking for ways that we can make recommendations. So it becomes more prescriptive guidance. Just telling you that something bad is going to happen is not enough. We want to be able to say, here are the things that you can do to mitigate your risk, to optimize your outcomes, to hit your specified dates. It really depends on what the algorithm is looking at, what the use case is, the type of recommendations that we'd be offering. But we really want to make this actionable. That's the goal. It's not just data analysis for analysis' sake. There are a few of us who just love that, and that's enough. I'm guilty of being one of them, but for most people, and here's where the product really becomes so much more valuable, is is how can we help you improve your processes and optimize your outcomes? That's really the goal with this. Okay, let's see, and here we go. Okay, now I feel the need again to issue the disclaimer that we're talking about a rolling 3-year roadmap, and what I'm showing you here with the framework is our longer-term vision for this product. Not all of these capabilities will be available in the first release of Predictive ALM, but we wanted to give you a sense of where we're going, the journey that we're on. And we're looking across the whole software development lifecycle. And again, here is where all of those data integrations in Next-Gen ALM become so important. And with many of the things that we're looking at, it's absolutely possible today to do them, but it's much easier on Next-Gen ALM when we have all of more of the integrations built kind of inbox, sort of by default. So it's easier. Okay, now you can see that we're mapping this to planning, development, testing, and operations. You can think of that as production. I'd like to start talking about the testing because this is actually where we are beginning our development, and the technology preview that we're going to be demoing in a minute is focused on the defect convergence. We are starting with this very intentionally for a couple of reasons. One, we know that many of our customers have a great deal of data associated with testing in ALM. So we want to lead with our strengths and go with the areas where today, we can show value by helping you analyze what you've already got. That you're not looking at waiting, 18 months, 2 years, or whatever your time frame is to adopt more tools, but we can show you value today. And there's a great deal of data in ALM associated with testing. And so some of the things that we could be looking at, and I'll even go so far as to say these are some of the things that we're looking at now, are in terms of accelerating the detection and the fixing of defects. That's really what we want to accomplish, is helping people get more efficient and more accurate in these areas. So looking at defect injection rates, fix rates, perhaps even being able to identify early on in the cycle which defects, while you're still in development, would be likely to cause escalations in production or cause problems in production. Reuse of tests, that is a very frequent request that I get from customers. Being able to, another one that's not appears, anomaly detection, being able to identify tests that are problematic. Now, we're also looking at the development and the production side kind of simultaneously. When you think about the coupling testing data with operation or production data, to me that's a huge leap in delivering on DevOps solutions that I think that many people right now are existing and challenged by organizations that are very siloed, and our data tends to be siloed as well. We have started looking at combining production data with our test data. I don't think we'll have time for it today, Matt, but that might be an interesting future webinar to demo that capability, where we can compare what people are actually doing in production to what tests are covering, and then identify the gaps, which if you're not testing for something at all, that represents a large potential risk. You don't know exactly what could go wrong if you aren't aware that people are doing it. And so making recommendations about what you need to do to either change tests or create tests to get better production coverage, we think that absolutely would provide a lot of tactical value. And then with the development phase, I don't want to give away too much of the Next-Gen ALM roadmap, but we will have source code repositories in Next-Gen, and I think that that opens up many very interesting use cases when we can start analyzing the source code and the metadata associated with the source code in combination with the ALM data that we have around requirements, around tests, around defects. And I think that opens up a lot of insight that, again, right now is not possible because all of this data and these groups are existing in silos. And then as a product manager, I'm very excited about a lot of the planning capabilities. You'll see some of those in AGM already, our Agile Manager tool. They've made a lot of investments in improving the planning process. And I know from personal experience, and this has been challenging for me throughout my career, that if you start with estimates that are inaccurate, that everything cascading off of that is also going to be inaccurate. And so you're looking at then cutting features or changing dates, and it creates more headaches down the line. So I personally am very excited to see us improve our own planning process by using these and then being able to share it with customers too. So Matt, are there any questions? I think you're watching the questions while I'm talking. Any questions I should be aware of or you want to address right now? Or any points that you think I've missed that we want to be sure to share?
Well, there's a lot of questions around the algorithm about whether we're able to tune the algorithm or exclude variables to adapt, things like that.
Okay, like about one of them specifically, or about the defect convergence?
My guess is actually anything. So what's currently available now, whether we can tune that, or whether in future we're going to provide that tuning ability to the customers.
Okay, that's a great question. And so let me explain a little bit more about that. Each and every use case that we're talking about is really a separate algorithm. Now, there may be pieces that we'll be able to reuse. That's something that we're looking for over time so that we can accelerate our own development. And we're absolutely learning from every algorithm that we develop. And before we even share it with customers, like we are now in the technology preview, for the defect convergence one specifically, let's talk about that. We've been working on that one for about a year, and we started it with several of our own very large data sets. We had to tweak it to refine it until it had good predictive capabilities. And then we started validating it with customer data. And I think we had, if I remember correctly, and Shal, you can come off mute if I'm wrong, around 10 large customer projects that we then used to, again, tune it, to tweak it, to improve the capabilities. And we got it to the point where we're seeing between a 40 to 50% increase in accuracy with our algorithm versus a naive algorithm where you'd just be looking at a mean or other measures of central tendency in terms of how long it would take for a defect to converge. And so this adds definite value. It's a much stronger, more accurate predictor. And what we're doing now with the tech preview is sharing it with customers. And I'll talk more about how to get it in a minute. And then we're looking for feedback on that because we want to continue to improve it. And so I think that, as Matt said, with all of this, with the algorithm development, it's really a process of continuous improvement. And as more data is introduced, as things change over time, then it will continue to improve. And then in terms of customers being able to do their own tweaking, the algorithm is run on your data. And so it really depends on, in large part, the quality and the consistency of the data you have. Are people using the tool consistently? Are they updating the status in a timely manner? Are they using the severity levels to mean the same thing? So the more homogeneous, the more consistent your data is within a project, across projects, the better the predictive capabilities the algorithm is going to have. If there's a lot of variation from team to team, from project to project, then it's much more difficult to get accurate predictions because it's sort of the garbage in, garbage out principle. And so that's really the focus of the white paper, which is available as a handout in the webinar, is about offering guidance right now, today, about what you could do with your ALM projects to get them ready, not just for the predictive defect convergence algorithm, but for the other ones that are on our roadmap and you'll be hearing more about in the coming months and years, as we release them as tech previews and then as GA versions. Okay. Any other questions you think we should address now, Matt?
Nothing right now. I know a lot of people are just saying we want to see the demo.
Okay, yes, that's the most exciting part. I want to get to that too. And sorry if I got really loud. You can hear my excitement. Okay, can you see what I'm sharing now, Matt?
Yep, you're good to go.
Okay, great. So I am so excited, and I have to give a shout out to Shal and Iran, my awesome R&D folks, who got this demo up and running. This is actually running on ALM. We can support versions 11.52 for QC and ALM. 11.52 and newer with this. The tech preview is available as an add-in to ALM. That's how we have it running here. There's also a SaaS version that's available. I think we have one of our upcoming slides has all that information, and it will also be included in the email that goes out. So you can see I'm looking at the defects module here. This is, again, standard ALM. I'm now going to look at the filters that we have. And you can use any of the filters that are available in ALM. And I have to say, I've had a lot of fun kind of playing with this and looking at applying different filters and different subsets of defects. You can actually get it down to the developer level and see, you know, for example, how long it would take one person to fix the defects assigned to them. For this demo, we're going to look at the critical or high defects and a new status. So I'm going to apply that filter. And we're looking at a subset of our defects now. I'm going to click on this little prediction button that looks like a column chart. And it's going to calculate. It's running the algorithm in the background on our data, on this subset of data. And again, I can look at any subset. I can filter down to a specific team. I can look at just critical bugs, defects, you know, any way you want to look at it. And I encourage people to try it out, to play with it. The default is a 95% confidence interval, but you can change that. If you're okay with more uncertainty, you can kind of get into some what-if analysis. So you can think of the confidence interval as, what are my chances? What are my odds of closing all of these defects by a specific date? And so here's this listing of the subset of defects that we're talking about. If I click on this button, I see a cumulative area chart, and I can see, you know, the confidence level is over here, and then the projected date in the future. And so I can watch what happens if I change this. If I want to say, right, with 99% certainty, then it goes to March 4th. If I want to say, all right, what happens if I'm 80% confident? February 27th. I can also look at changing the number of developers. So what happens if I put 10 developers on this? How would my dates change? So again, we're enabling some what-if analysis. And you do reach a point where adding more developers really doesn't help you reach a closer date, much like in real life. Throwing more people at a problem does not always accelerate your development, or it only does up into a certain point. The other way that I can look at it is, all right, if I've got a certain date in the future that I need to hit, what are my chances of getting there? So if I were to click, you know, January 28th, I've got really zero chance of closing all of these defects by then. Okay, February 11th, if I want to be aggressive, I can say, all right, I've got a 78% chance of closing the subset of defects that I looked at by February 11th with 10 developers. And so again, I can change these parameters and see what happens with the estimates. And I'm so excited that this is available today for everyone to try out. So Matt, anything you want to add about this, or any questions that we want to address?
No, I think so far so good. I mean, I always like seeing it as well, because I think it's just a very slick user interface. So nope, so far so good.
I like it too. You know, I'm a sucker for data visualization. I love the charts, love the clean lines, and I'm so happy that the demo is working and that I'm actually able to show it live. I think it makes it more real than, you know, showing a video.
Absolutely. Yep, agree with that 100%.
Okay, so let's go back to our slides, and here we want to show. Where are we? Show the demo. Okay, so. Here, maybe I should have talked about this one first. So maybe not. I think I talked through these things as I was showing the demo. So as I said, this has stronger predictive capabilities than a naive algorithm, and we're really interested in feedback from our customers on what they're seeing when they run this on their own data. We know from our own development experience that we tend to use our tools differently than customers, and we want this to be as accurate as possible. So we are soliciting input from people so that we can improve it over time. Okay, and so how can you get it? And Terry, I believe these links will be available in the email that we're sending out too. This PowerPoint deck will also be available. The bits are posted on HP Live Network. As I said in the demo, sorry, is somebody trying to say something?
Yeah, it may just be background noise.
Oh, okay. Okay, I'll keep going. So available for QC or ALM 11.52, 12.02, 12.5. It will work as a simple add-in for any of those. We tried to make this as easy as possible for customers to get. And, we love our customers, and we are excited to share this with you. We want to show you the direction that we're going in, and we think that this is actually a handy algorithm. It's very useful, so we're excited to get it out there. We've provided a user guide. All the instructions are available on how to install it, and the white paper is also posted up there. It's available as the handout in the webinar too. I suggest, please take a look at it. I tried to make it understandable for anybody who doesn't get excited about data science, so I hope that it accomplishes that. And then for SaaS customers, it's actually even easier. All you need to do is email predictivealm@hpe.com, request the predictive defect convergence algorithm, and we can turn it on our end. Matt, are there any questions?
We have a lot of questions. I don't know if we want to grab a few of them now, or, well, yeah, let's get the white paper. We'll talk about the white paper, and then we'll go through, because there are quite a few questions. I'm glad we left enough time for them.
Okay, great. And I'm in projection mode, so I can't actually see any of the questions. I can get out of that if you want me to. So, right, the white paper, as I said, and Matt, feel free to jump in on anything else with the white paper too. I kept getting questions from customers about what should I do, how do we do this? And so I wrote this white paper, again, like trying to make it accessible and really clear about here are the very specific things that we recommend that you do. I put in kind of the best case scenario. Here's what we are recommending everything. Even if you only do some of those, it's still going to be of benefit when you start using the predictive analytics. I tried to make it clear, and most of the things that I've highlighted really are just best practices. So you don't even have to wait for predictive ALM to reap the benefits of doing these. You'll see some benefits right away, like being able to look at things across projects, getting your teams to use things more consistently. So I tried to make it as clear and easy to use as possible. And Matt was my test reader, and he kept saying, no, this is too complex. No, back to the drawing board. He was a real taskmaster.
That's true. That's true. I'm losing my technical chops over time here. So as I'm getting into the details, I'll be like, Megan, this is too complex. Help me figure this out. So yes.
Megan, say that in English instead.
That's right. Exactly.
Okay, so Matt, do you want to throw some questions out there?
Yep, let's do that here. So the first question that came up actually was a number of customers are segmenting their ALM projects by domain. Are we going to be able to do predictive capabilities across domains or across projects?
Across projects, absolutely. Across domains, good question. From a technical perspective, yeah, there's no reason why we wouldn't. I think it would just have to be specified when you're configuring the predictive ALM. Like, this is going to be a separate product. Right now, we're sharing the algorithm that we're talking about today, but eventually this will be a product that is closely coupled with ALM, but not part of ALM. So I think when you're configuring that, you would just need to specify where you'd want to pull the data from.
Right, and again, it's maybe worth reiterating. So this is the first piece. It's a bit of a teaser for everybody, but ultimately there's going to be additional functional areas that we'll be looking at releasing over the next likely year or years, depending on how much stuff we want to keep growing the suite with.
Well, I think, and this is my opinion, I think that once we start putting the algorithms out there that we've identified, and this is a good point for me to mention too, you may be wondering, well, how did we prioritize these? How did we identify them? We did some really large market research studies to identify what are the biggest pain points, what are the biggest headaches that people have today across the software development lifecycle. We cast a broad net. We interviewed about 700 people, not just our customers, but kind of everybody who's out there, broad sampling from the planning through development, testing, and production to be able to quantify and prioritize what are the biggest problems. And that's what we are using to prioritize our own backlog for the algorithms, because we want to focus on the things that are causing people the most pain and where we think we can add the most value. And so I suspect that once we start working down that list, we're going to uncover other things. And I see this as a longer journey that we've identified the ones we want to start with, but as we get feedback from customers, as new tools are introduced, as new challenges arise, there's an opportunity for us to address those with algorithms too. And I think with data science, I think part of it is art, and anytime we're making the predictions, it's never 100% accuracy, but what we can do is reduce uncertainty. And even if we can reduce the uncertainty by 50, by 80%, that's a big improvement over where we are today.
Actually, that's a huge point. You're right. In a lot of cases, we're not looking for the answer is 7, but we're looking to say, well, where's the likely area I should be focusing in on? Is it a certain number of defects? Is it a user? Is it my, part of my architecture? That kind of stuff.
Right. And so you're right. Instead of saying the answer is 7, it may be the answer is between 6 and 8. Yes.
Yeah, exactly. Yeah, that's actually a good way of putting it. Okay, so let's see here. So are there going to be different, I guess one of the questions was, will there be multiple algorithms to select from, or will it be just an algorithm for an area and then we can maybe tune that algorithm if we need to?
There probably will be. Well, they're going to have to be different algorithms because they're very specific to specific use cases. It's not like there's just one general purpose algorithm that we could use for everything. And I'm envisioning it as really being kind of different modules, like where are you looking across the life cycle? What is the challenge that you're looking at? And then, we will be adding to the product over time with new algorithms. And you saw the framework, you see the vision of where we're going, and we will continue to innovate and add to those over time.
That makes sense. So one of the questions, and you might have expected this kind of a question, are you able to name some of the machine learning algorithms that we've tried, and what have we found useful in maybe other contexts?
I'm wondering, did that question come from Ohad, our data scientist, as you tried to
believe it or not, it did.
Okay, I'm just teasing. So there are several, and some of this is our IP, so I don't want to give too much away. Decision trees, forests, cluster analysis, the HPE labs are doing some interesting things with kind of an iterative cluster analysis approach. So there are some standard techniques that anybody can read about in academic journals or books, and then we have some really smart data scientists who are working internally, and then they've developed some additional things. Am I being specific yet vague enough, Matt?
No, I think that's good. And I think you hit on a very important point earlier, which is this isn't going to be a solution that we'll drop a version 1 of. It is going to evolve over time. And if you think about the industry as a whole, the software industry is also adjusting. I think you made this point, Megan, earlier that in a year from now, the software industry may be way into something like a DevOps world, or we may be thinking far more into the Agile world, or maybe neither. And so we wanted to create an architecture and a system and a framework that we could evolve and deal with the challenges, as things work over time, not just say, here's your tool, here's your algorithm, go enjoy yourself, because the world isn't static like that, and we know that. I wish it was sometimes, but it's not.
Right. And I also want to say, Matt, you bring up a really good point, that I believe that all of our customers are going to be hearing more about predictive analytics, predictive and prescriptive capabilities, big data analysis, really across the HPE portfolio.
Yep.
And as you know, Matt and I have a virtual team of different product managers, developers, etc., really around HP software and some hardware folks and big data, where we get to share best practices, learning, and there's so much excitement around this, and so many people kind of see the internal assets that we have, Vertica, autonomy, and then a lot of the things coming out of HPE Labs that are really innovative. And so I expect, and this is my opinion, that you're going to hear more about that really across our portfolio, that other people are seeing the same opportunities that we are in terms of analyzing dark data and helping customers really make more informed decisions and more informed trade-offs or mitigating risk. You know, the security folks are doing a lot of exciting stuff too. So, you know, that's I guess my plug for all of HPE.
So that makes sense. Now, do we have, I guess one of the questions I thought was interesting, this came up, actually, I had the same question myself last year. When we're talking about defect prediction, are we looking at anything like maybe predicting the chance that specific test cases will find defects?
Oh, okay, so that's slightly different than what we're talking about with the predictive defect convergence. That actually is on our radar and something that our data scientists are investigating now. I think that there's a whole lot that we can do with defects and with tests and with all of the ALM data that we have, that customers have. So I'll give kind of, I guess, a preview of coming attractions that over the next several months, we're going to be talking a lot more about that.
Okay, so another question here, which I think is, again, an excellent question. Are there any limitations to the number of defects, or on the number of defects which can be used for the actual prediction? So for example, if a project has only a handful of defects, maybe 10 or 20, does prediction still work, or do we need a larger set of data?
Oh, that's another great question. And Shal, maybe you want to come off mute. Because I'm trying to remember the specifics. I think we have this in the user guide, but I could be wrong. I want to say we're looking at around 3,000 defects in order to have strong goodness of fit measures. If you've got fewer than that or more, you know, it is possible, but that's kind of the minimum that we're looking at, if I remember correctly. And then in terms... Oh, hi, Shal. Oh, good.
Hi, everyone.
Am I remembering correctly, or is it a different number?
I think it's actually slightly, obviously it varies from project to project, depends on various factors, but generally speaking, I think we need a few hundred defects to get decent results. Obviously, as with any predictive algorithm, the more accurate, the higher the number of training data that exists, the more accurate the algorithm will be. But I think we get decent accuracy from a few hundred defects which have completed their life cycle. As in, unless it, we know how long it took to fix, then we can't learn for future defects. So a few hundred defects which have been fixed already.
Okay, thank you. Thank you for clarifying, and I'm glad that it's a lower number. I think I was remembering the size of the projects we were looking at to analyze for tuning the algorithm before we even shared it in the tech preview, so thank you. And the duration that you would need, it really varies greatly by team, by project. For some groups, getting 500 defects would be a matter of weeks. For others, it's longer. You know, it really depends on how long it would take and how many people you have working on it, really the size of the project. So thank you, Shal.
Yes, thank you very much. So I've got a couple of other, maybe there are deployment-related questions here. So the first one is, which versions, again, are we supporting with this?
Oh, sure. Here, let me go back to that. Yep. QC or ALM, 11.52, 12.02, or 12.5.
Now, is 12.21 supported within there as well? Because it was sort of a minor release.
Yes, I believe so. Yeah.
Yeah, I thought it was as well, because 12.21 shares the same data model as 12.5 effectively.
Right.
So 12.21 should also be supported.
Yeah.
The other question, I know we talked about this, but worth reiterating, Predictive ALM isn't using a new database. We're actually using your existing ALM database that you've already got, right?
Right.
So that definitely makes it a lot easier. You're not having to reinstall or recorrelate data. You've actually got a lot of what you need to get going out of the box as you start working with this stuff that you've already been using in ALM today. Will partners be able to create and use their own algorithms?
Will partners be able to create and use their own algorithms? Oh, you mean for the predictive defect convergence, or like in the product eventually?
I think eventually in the larger scope of things.
Okay. Yes, I think so. We have not gotten that far yet in terms of how we would architect it, and we could eventually, not right now, because we're still building so many of these algorithms, but longer term, I think we would consider exposing some APIs. But there's probably going to be either use cases, challenges that are very customer specific that are not things that we would build into the product. So I think that, in any domain, you'd be looking at some algorithms that would be more targeted to just certain customers, and then, I would recommend that, partners or customers themselves, if they've got their own data scientists or teams to do this, that they would be looking at building those specifically themselves. That's not something we would put into predictive ALM. We're trying to focus on broad market needs.
Which makes sense. All right, so a couple tougher questions here, just to prove that we're not completely seeding the pond here with easy questions for us, which would just be great. But so the tougher one here is, so when we did the demonstration, or you did that a little earlier, does our algorithm assume that the number of developers are working only on fixing defects and really nothing else?
No, it's really based on the number of developers that you've had working on it previously. So we're kind of assuming in the algorithm that whatever happened in the past is really what we're using to calculate the future, the prediction. And so let's just say, for example, that you had 5 developers who were spending 30% of their time, and it took them X number of days to fix these defects. That's what gets built into the model. It's whatever happened in the past in your project. And that's why Shal pointed out that it's important to have a repository, a history of defects that have gone through the whole life cycle, so we could see what actually happened. Now, I also want to point out that this is a general kind of data science principle, that points that are closer in time are more closely correlated. So more recent projects where you had potentially the same people working on it, or the same type of development, that's going to be more closely correlated with what would happen in the future. So it would give you better predictive capabilities versus something that happened 5 years ago.
Right, and which makes sense because, again, the world changes so quickly.
Right.
Okay, so a much tougher question, and I'm sure you've got a good answer for this because we've talked about this in the past. Don't the results ultimately depend on the correctness and the consistency of the data? And does the tool help to clean up any data structures, or are we just leveraging what's already in it?
So absolutely, that is the main point that I tried to make when talking about the white paper. Absolutely depends on the quality of the data that you have. For our tools, no, we're not with this algorithm, nor do I envision us cleaning up existing data as part of predictive ALM, because again, that tends to be more like project or team or company specific, how you would need to do conversions or other things. The best practice recommendation that I can make, and I'll say it again because I think this is really important, is to make sure that people are using the tool consistently and accurately. Like if a defect is open and it stays in new status until it is closed, then that really doesn't help us figure out exactly how long it took to fix or whether things were reopened or reassigned, etc. So you want to make sure that people are using the tool consistently and in the way that you intend, whatever best practices you want to use, but ensuring that people are using it that way. And that's what the white paper talks a bit about too.
Excellent. Okay, so again, we talked about this before, and I'm always interested in maybe hearing this, or some of the folks here would. Could this actually work with data that we've imported into ALM from a competitor tool?
Yes. Yeah. From a technical perspective, yes.
Because again, it's
transformation would need to happen. That might depend on what the data is. So I'm going to issue a general yes, it's possible. Getting into the specifics, we'd have to look at exactly what data we're talking about and what kind of mapping or transformation would need to happen.
Yeah, because that's the big one. Is ultimately the data needs to look in some way that it feels and can be interpretable as an ALM data. But we do that already. There are a lot of different competitor tools we pull data in already from. So.
Exactly. So if it's one of those, then yes, we might even have a solution in box already. Otherwise, we might be looking at something custom. If it's like a homegrown tool, for example, that would probably be something custom. Or our partners also have many adapters. So technically, yes, absolutely possible. The ins and outs of how we do it, we'd have to look at the specific data and then give a more accurate information. Does that make sense?
It does. So, and the other question, I guess, was around just implementation here. If we're doing the SaaS add-on, do we know if there's any downtime required for the SaaS instance in order to turn on that algorithm?
I don't think there is. Like they've already turned it on for some customers. I want to say, and I could be wrong about this. Shell, maybe you remember specifically what Oren told us. I know it's pretty quick, within a day, maybe faster. Shell, do you remember?
No, I don't think there's any downtime needed for it. It might take a couple of days till it's actually installed, but during that time you'll be able to carry on working as usual.
Yeah, that makes sense, because we're annotating the data that's already in the system. We're not actually doing anything in the system itself. We're just reading instead of writing. Mm-hmm. Let's see here. I'm trying to think of anything else here that may be worth asking here. A lot of questions around next-gen ALM, which is interesting.
Well, okay, great. I hope that people are getting excited about that too.
It is, and actually, again, so stay tuned. We're working on securing a date in March to be able to talk more about next-gen ALM. Even though it's next-gen ALM, don't look for a big bang, version 13 or version 14, but it'll be fairly well communicated that it's a big deal. Now, again, not a new product. Next-gen ALM is not forcing you to buy new stuff. If you've got ALM or Quality Center Enterprise today, it's the logical upgrade path. The predictive, and again, to clarify, the predictive defect convergence that Megan demoed today, that is available already today for Quality Center and ALM customers. You can get it on the HPE Live Network or HPE Live Network. You do have to be logged in to the system to actually get it. But in future, some of the new predictive capabilities we're looking to build that have not yet been built, those are likely going to be a separate offering that you can add on to your existing tool set.
Correct. Oh, Matt, are there any other housekeeping points we need to make? I know we've only got like 2-3 minutes left. Anything about the survey, the follow-up, anything?
No, I think so. Yeah, okay, there you go. Yes, sorry.
Could I make one comment, because I do see that some people are having some trouble with the handout and or some of the links, and I do want to just let everyone know the links were all tested and the handout does open. If you're having troubles, my guess is that you may have a blocker in your firewall that's not permitting you access. So you might want to try it from a personal computer or away from your business. I can email directly the white paper and such if they need it. They can send a note to the Vivid website.
Right. The white paper is available on the HP Live Network. There's another site where Matt posted it. So if you're unable to get the handout, there are several other ways we can get it to you.
Yeah, actually, it's a worst-case scenario if you're stuck and you want to get the white paper. If you go to the HPE ALM main product landing page, one of the additional resources, actually the first additional resource, will be that white paper. So there are a couple different things there. I think that's it as far as some of the main questions. Again, we could get into detail, and we will actually. We'll answer a lot of these offline and then post some of those answers after the session is completed here. I guess, Megan, if you want to scroll to the very last slide.
Sure.
We'll just leave. Here we go. Just the last little bit here. So again, if you could just complete just a short survey, and if you have any questions or want to get more information, please reach out to us as well. But we'll be posting the actual presentation, and again, the answered questions that we weren't able to do in this session here, as well as some of the links on the Vivid site afterwards as normal.
Right, and the recording will also be available. Terry, what did you tell us? Within like a day or two?
Yes, they'll get a follow-up email probably tomorrow, and the recording and the presentation will be at that link.
Okay, great.
Excellent. So I think at least at this point, I think we're done for now, but we definitely appreciate everybody sitting in on the session here. Again, there'll be more stuff that we'll be talking about with Next Gen ALM, as well as some of the new predictive stuff. So stay tuned for some of that stuff coming up in the near future. But again, we really appreciate everybody taking the time to sit in and listen and learn some stuff here with us this morning.
Yes, thank you so much for your time. Thanks for the great questions, and we will answer all the ones we didn't have time for today. I encourage you to go out and try out the tech preview and share your feedback with us. We're really excited about predictive ALM and the direction that we're going in, and we're so happy to have you on this journey with us. So thanks, and thanks for moderating, Matt. We're awesome.
Oh yeah, no, thank you. All right, guys, have a great day.
Okay, thanks. Bye.